Hello, you're welcome to this video. I am Nkwagbade. Today I will be guiding you through lesson 2 of the topic scale drawing. In the first lesson, we introduced the idea of scale drawing, and I hope that you had fun introducing it to your learners. That was just an oral aspect of the work. Today we will go into calculation because what is mathematics if calculation is not involved? Today we'll calculate scale factors and see how they are used in real life problems. But before that, let's explore what we're going to be learning today. We'll define what scale factor is and why it is very important in scale drawings. We'll look at the procedure for calculating scale factors, the formula, and we'll look at some real life examples. The formula that we're going to be using are scale factor equals scaled measurement divided by actual measurement, or what we call the model size divided by actual size. This formula is actually very intuitive to understand, so I would encourage you to help your learners gain the understanding of it instead of having to cram it. Say we have a standing fan that is 50 centimeters tall, and then we reproduce the standing fan on paper. It is now 10 centimeters tall. How much taller is the real standing fan than the paper standing fan? Well, if it is 50 centimeters in real life, and on paper it is 10 centimeters, then it is actually 5 times of the paper length, because 10 times 5 is what gives 50. So in this scale, the scale factor is 5. And how do we arrive at this 5? By dividing 50 by 10. We actually divide 10 by 50 to get 1 over 5, and our scale factor is 1 to 5. And that is what scale factor formula is all about. To get the scale factor, divide the paper length or the model length with the real length. And that is the formula that you have here. Let's look at some examples. The first example says a skyscraper is 150 meters tall, and on the scale, on the drawing, it is 30 centimeters tall. We are to calculate the scale factor. It's actually very easy. I've just explained the whole process. We're going to be looking at it together. Here is the example again. So the scale factor is calculated by dividing the scaled height, in this case it is 30 centimeters, by the actual height, in this case it is 150 meters. So we're going to be writing 30 cm divided by 150 meters. Now we cannot just divide through, because we have to remember that centimeters and meters are not the same. We have to convert them to the same units. So to convert to the same unit, we'll multiply this by 1 and this by 100. So because 100 centimeters actually make 1 meter. So 30 centimeters in the numerator, 150 times 100. Well, we can just leave it like that, knowing fully well that our final answer is now in centimeters by multiplying by 100. Then we can divide out. This 0 here can cancel this 0 here. Now 3 goes in 3, 1, 3 goes in 15, 5, 3 goes here, 0 times 10. So we're going to have 1 over 500 and this is our scale factor. We can write it also as ratio 1 to 500. What this scale factor means is that the real building is 500 times of what is on paper. So when you see the drawing on paper, know that the real building is way bigger than that. It is 500 times. Let's see. Oh yes, we got that right. Our final answer is 1 to 500. That is the scale factor. Let's look at another example. For this example, it is said that a river is 200 meters wide, and that the map representing it actually depicts the river as 10 centimeters wide. So on that map, when you look at that tiny river on the map, it's not that tiny, it's actually very wide. But what is the scale factor used? That is for us to find out. So telling the children, we'll go over to our page and do that. Here is the example. The river is 200 centimeters wide and the map represents it at 10 centimeters. So to calculate that, we're going to do scaled measurement, which is the paper measurement, divided by the actual measurement, which is 200 meters. So we're going to have scale factor equals 10 centimeters divided by 200 meters. Now we have to ensure that, again, the units are the same. That is very, very critical, because 200 meters is not the same as 200 centimeters. So to change meters to centimeters, we got to multiply by 100. And so our scale factor will be rewritten as 10 centimeters divided by 200 times 100. We don't need to multiply it out yet. Rest assured that our final answer will be in centimeters. Then we can divide all through. 0 cancels out. And then we have no common factors in the numerator and denominator. So we just divide it, and we just multiply what you have in the denominator. In the numerator you have 1, in the denominator you have 200 times 10, and that is 2000. And so the scale factor is 1 over 2000, which of course we can write as 1 to 2000. So what does that mean? It means that the river is actually 2000 times wider than what it is on paper. And what helps us to get that? It is scale drawing. Let's see if we're correct. Should we want 2000? Yes, of course it is. We are correct. A third example, we have a car that measures 4 meters in length, and the model for the car, the toy model, the one that children play with, is 8 centimeters long. So what is the scale factor used to reduce the big car to that small model? That's for us to find today. So work with the children to find this. I'm going to do that on another page here. So the example is here. So we have that the scaled measurement, of course, over the actual measurement. That's how we get our scale factor. So write SF equals 8 cm. The factor is 8 centimeters over 4 meters. Again, we must remember that the units have to be the same. So we're going to change meters to centimeters. We're saying 8 centimeters over 4 times 100. And then everything will now be in centimeters. So we can divide with common factors. 4 divides here 1, 4 divides here 2, 2 divides here 1, 2 divides here 50. And now we have in the numerator we have 1, and in the denominator we have 50. Now our scale factor will be 1 to 50. And what that means is that the actual car is 50 times bigger than that toy car that children are playing with. Let's see if we are correct. Yes, of course we are. On the final example, told that a garden is 8 feet in length, and on the scale drawing it is 20 inches long. This has nothing to do with centimeters and meters. This is feet, inches, and yards. So how do we do that? Let's walk through it together. Examples right here. So we have that the scale factor is the scaled measurement is 20 inches, and the actual measurement is 80 feet. So using the same formula, the same idea, 20 inches divided by 80 feet. Except now we have to change 80 feet to inches. So how many inches make 1 foot? That is 12. 12 inches make 1 foot. So to change the 80 feet to inches, go to multiply 80 feet by 12. Now, so that is inches. And now we can divide through. 1 0 can cancel here. 2 goes here 1, 2 goes here 4. And then we are all done. In the numerator we have 1. In the denominator we have 48, because 4 times 12 is 48. And you must notice that in the scale factors we don't include the units. That's because scale factors do not have units. You can as well say that the inches cancel each other out, centimeters cancel each other out. So we have just 1 to 48. We'll write this as ratio 1 to 48. And that means that the garden is actually 48 times what is on the plan. So let's see if we are correct. Of course, we are correct. Here it is right here. The garden is really 48 times the size of what it is on paper. So we have your class activities are there. You guide the children through these activities and then give them the password. And I trust that you can work out the password on your own. If there are challenges, then you can drop the challenges in the comment box, and I will be willing to answer your questions at any time. So for now, we're done. I'll see you in lesson 3. Till then, see you then. Bye bye now.